All right, folks, we are back to chapter 10 for our Cisco CCNA journey. And so what we're going to talk about here, because again, chapter 10 covers rapid spanning tree protocol and Etherchannel, right? And you guys are going to learn this through configuration, right? So um, where we're at now is identifying optional spanning tree features, right? And one of the features I wanted to speak about today is port fast and BPDU guard, right? So what is that, right? So just like we talked about, right, in chapter 9, right? Port fast, it provides a useful feature, right? And to where whenever we learned about the 5 states within spanning tree as far as convergence, it's port fast skips listening and learning and goes immediately to forwarding whenever an electrical signal or fast link pulse is detected on a switch port from a PC or a host. Okay. All right. So BPDU guard is exactly what it sounds like, right? BPDU guard blocks a switch port from receiving BPDUs. Okay. So what we're going to do today, we're going to go ahead, we're going to hop on the switch, we're going to configure port fast and BPDU guard, and we're going to see the difference, right? Differences between, connecting a PC and connecting a switch. Okay. So switch one is going to be our example. Okay. So let's go ahead and pull that up. Excellent. Let's see. Excellent. All right. So it has, whoopsies, typing wrong. All right. So we have that. Let's check our configuration. Every time we log into a switch, we want to go ahead and do that. Excellent. Right. So any of our interfaces, we do not have any configuration at all. This is what we wanted. Okay. So what we're going to do is we already using gigabit 0/0/0/1, right? So what the next interface after that is interface gigabit Ethernet 0/2. So we're going to go ahead and use that, right, as our example, right? So let's now we're in user exec mode. We need to go ahead. I'm sorry, we're in privilege exec mode. We're going to go ahead and go to global configuration mode. Okay. So let's go ahead and do that. Okay. And let's make that change. Okay, let's go ahead and make that change on the interface. Okay, awesome. Right. So let's go ahead and enable port fast first. So we're going to type spanning tree, right? And we can use the question mark. You see plenty of options here, right? We have BPDU filter, BPDU guard, right? We also have port fast, right? We're going to go ahead and configure port fast, right? Awesome, right? We have that set. Um, and again, you see this, and this is what I love about Cisco switches, right? Cisco goes ahead and gives us a warning log, right? That says, warning, port fast should only be enabled, right, on ports connecting to a single host, connecting hubs, concentrators, switches, bridges, etc. to this interface when port fast is enabled can cause temporary bridging loops, right? Why is that the case, right? But what did you guys learn? You guys learned, excuse me, you guys learned, right? Is that listening and learning phase, whenever we're connecting two switches, it's very important because it needs to go ahead and go through the process of going through that negotiation, right? Seeing who's has a better bridge ID, et cetera, for the convergence to properly build a tree. If it doesn't have that time, what happens, right? We could potentially skip that process, start forwarding frames, because that's one of the 3 major functions of a switch, right? And then mistakenly cause a spanning tree loop. We don't want that, right? So if we're going to enable port fast, what should we go ahead and configure as well? BPDU guard, right? So let's go ahead and do that, right? Because we don't want that to happen, and we're expecting to only connect a host, one host, right? Or a host to this interface, not a switch, not a hub. Okay, so let's do that as well. Spanning tree, and because I can forget BPDU, then we're going to type guard. Whoopsies. And it's asking for something else. Awesome, we're going to do enable. Yeah, some commands they do require enable on there. All right, excellent. So that's done. I'm going to go ahead and log back in Sometimes with even G, it does timeout. Try that again. There we go. Let's get that shot. Awesome. We're back. Okay. All right. So we have that. And what we're going to do, we're going to go ahead and first plug up this PC. All right. 0. And we made a configuration on gigabit 0/2. Save our config. Awesome. Let's go ahead and check our switch. Oops, that's not what I wanted. There we go. All right. So what can we see here, right? We have some syslog messages that popped up that says, hey, interface gigabit 0/2, right? The state changed to being up, right? And that's just layer 1, right? And then the line protocol, which you guys learned in earlier chapters, um, and that means layer 2, right? That's another term for layer 2 on switches, right? Layer 2 is up as well, right? And that was instantaneously, okay? So we're clear here, right? This is how quick in the great effect of configuring port fast on a switch port. Let's try plugging in a switch to this port. Okay, so let's delete this link. Let's go ahead and do that. There we go. Awesome. Let's move that PC over here and let's go ahead and plug in this switch. Now let's see what will happen. Ah, what do we see here? Right? So we see here a different message. Receive BPDU on port gigabit 0/2 on a BPDU guard and enabled port, right? We're going to disable the port, right? Also, another message that you guys need to understand for your career, right? With us having BPDU configured or guard, right? Since the conditions have been met, it has set that port into an error disabled state. Okay. BPDU guard error detected on gigabit 0/2, putting gigabit 0/2 in an error disabled state. We haven't gone over what error disabled is just yet. Okay, I will give you a high level definition. What this means, it is temporarily shutting down that interface for 500 seconds or whatever configured timer that you can have. 500 seconds. I believe it's 500 seconds or 500 milliseconds. I'll get the confirmation on that once we actually dive into error disabled mode. But once it does do that, that interface cannot be used. Let's go ahead and confirm that, right? So let's do a show interfaces. And do we got a brief on here? Show interfaces summary. Maybe we can get that. There we go. No, that's not the one number. Let's do forward. Let's see if it gives us that. Nah, it doesn't give me what I need. Okay, let's try this. There we go. Awesome. All right, so this is what I wanted, right? Is even though we have something plugged up, what is reflecting on layer 1 and layer 2? We have here status and protocol layer 1 and layer 2 is showing down, right? And this is in an error disabled state, right? And we also have the command to where we can go ahead and take a look at this, right? There we go. Yasin, I see you sent a message. Give me 1 second, right? So the timer interval is 300 seconds, right? It has you guys, can read, right? Once that 300 seconds is up, interfaces that will be enabled at the next timeout, right? So until you fix the issue, right? every for 300 seconds, 5 minutes, it's going to be shut down. If you don't fix it, it's still going to stay shut down. You can go ahead and bypass it by fixing it, bouncing the port, it'll be up. But here are all the error disabled reasons that could cause it to error disabled. And do we see one of our reasons? We have BPDU guard. Okay. All right. Let me go ahead. Yasin, I think you sent the message. Give me 1 second. I thought it stays in error. I thought it stays in error disabled unless you issue shutdown, no shutdown, or unless you specify a recovery timer. Yes, yes. I don't know if you heard that. That's what I shared, right? Um, what the switches control plane is going to do is going to go ahead and check at the end of that 300 seconds if the issue is not resolved, right? And this is without manual interaction. It's going to go ahead and re-enable the interface, right? Of course, if you fix the issue prior to 5 minutes, because of course some environments that's too long, you can go ahead and just bounce the interface. Bouncing meaning shutdown, no shutdown. It'll go ahead and pop right back up as long as the condition isn't met to put it in error disabled mode. Does that make sense?
Yeah, that makes sense.
Okay, cool. Um, and I'm not sure if I said it. You absolutely can change the error disable timer as well. Um, me personally, again, unless you have a knock, um, I wouldn't go ahead and configure that. I would go ahead and just let it stay at 300 seconds, right? So that, an issue can be noticed. And so that, once it's down to 500, 5 minutes, end users are screaming, now we know what we need to investigate. If it's, if we go ahead and put it quicker, 100 seconds, maybe we're not, and typically the NMS that you'll have, right? Maybe it's behind a layer, it's behind something that has layer 3, right? Let's say that switch has some IP addresses on it, right? Yeah, it has a couple of SVIs, right? If we set it to, let's say, 1 minute, right? Your NMS checking all your hosts every 5 minutes, what's going to happen? Now it may think nothing is wrong with it because now we have interval mismatch, right? So, you know, do what's best for your environment. But again, leaving it at 300, it's perfect. It makes us, work harder, but we're gonna have to, once we get a handle on our environment, what we allow, what we don't allow, we can go ahead and work smarter. With that being said, that's all for today. Come Sunday, we're gonna go ahead and cover some other things. Okay. You guys have a great night.
All right, thanks, David. Bye,
No problem.
guys.
Bye.